Hello there. In some videos ago, we discussed how to solve linear equations, where linear equations were something of the form 3x minus 2 is equal to 5. In this video, we're going to be comparing linear equations against linear inequalities, which are things like 3x minus 2 is greater than 5, or things like 3x minus 2 is less than or equal to 5. So we'll be discussing how to solve these types of things and what they imply in this video. Alright, to begin the discussion of linear inequalities, we're first going to consider a couple of things. So let's assume that x is bigger than a. So for some arbitrary variable, let's assume it's greater than a. So if x is greater than 5, then 6, 7, 8, 9, and 10 would also be true. So if x is greater than a, what we're going to prove is that this also implies that negative x is less than negative a. That is, when you multiply both sides of this inequality by a negative one sign, it will flip the inequality. So let's quickly go through a proof on how to verify that this is true. Alright, so we're going to assume that x is greater than a. Let's assume that x is greater than a. So if this is true, what we can do is subtract a from both sides of this inequality. So x minus a must be greater than a minus a. So this implies that x minus a must be greater than 0. So if this is true, what can I do? Well, I can subtract x from both sides of this inequality. So I can have x minus a minus x must be greater than 0 minus x. So what can I do? Well, this is just subtraction and it's not multiplied, so I can just remove my parentheses. So this is just x minus a minus x is greater than 0 minus x. So I have x minus x, and I can rearrange them since the commutative property of addition holds in this, because this is x plus negative x, so I can rearrange them, and they will cancel. So on the left-hand side of this equation, I have that negative a must be greater than 0 minus x will be negative x. And this is read as negative a is greater than negative x, which is equivalent to saying that negative x must be less than negative a. So in general, what we have is that x being bigger than a implies that negative x is less than negative a. So this is going to be a common strategy for solving linear inequalities, and this is pretty much going to be the only difference in solving linear inequalities compared to linear equations. So let's work through some examples. So let's solve the inequality negative 3x is less than 6. So the first thing I can do is I can divide both sides by 3. So the 3's will cancel. So I have negative x must be less than 2. So if negative x is less than 2, I can multiply both sides by negative 1. So if negative x is less than 2, by the theorem that I just proven above, x must be greater than negative 2. So if x is greater than 2, then any number bigger than negative 2 will satisfy. So if I plug in 0 into this equation, I get negative 3 times 0, which is 0, and 0 is less than 6. I can plug in 1. So negative 3 times 1 is going to be negative 3, which is less than 6. But negative 2 will not work because that's going to give us 6 is less than 6, which is not true. So in interval notation, we can rewrite this as x belongs to the open interval minus 2 comma infinity. Parentheses, not brackets, because we cannot include 2. So that's the interval notation representation. So example 2, let's solve a more intricate example. 4 minus 2x is greater than 3x minus 7. Alright, so I'm going to begin by adding 2x to both sides. Actually, I'm going to put my x's on the left-hand side, but it really doesn't matter. So I'm going to subtract both sides by 3x, so those will cancel. And I'm going to subtract 4 from both sides as well, so those will cancel. So I get, so negative 2x minus 3x is going to be minus 5x. That's going to be greater than negative 7 minus 4. That's going to be minus 11. So I can divide both sides by positive 5. So I get that negative x must be greater than negative 11 fifths. So if negative x is greater than negative 11 fifths, that means positive x must be less than positive 11 fifths, which is by the theorem that I had proven above. So any number less than 11 fifths will satisfy. So 10 fifths, 9 fifths, 8 fifths, 0, negative 5, and so on will satisfy. So that means any number in the interval minus infinity up to 11 fifths, but not including it, will work. All right, so let's work through another example. So let's solve 2 times 3 minus 2x plus 1 is less than or equal to minus 2 times 3 minus 5x minus 7. So I'm going to begin by distributing both sides whenever I can. So that's going to give me 6 minus 4x plus 1 must be less than or equal to minus 6 plus 10x minus 7. I'm then going to combine like terms on the sides as I can. So 6 plus 1 is going to be 7, so I have 7 minus 4x is less than or equal to negative 6 minus 7 is going to be minus 13 plus 10x. And now I'm going to isolate my terms as I need. So I'm going to subtract both sides by 10x. I'm going to keep my x's on the left-hand side, so those will cancel. I'm going to subtract 7 from both sides, so those things will cancel. So on the left-hand side, I have negative 14x is less than or equal to negative 20. From here, I'm going to divide both sides by 14. So I'm going to have that negative x is less than or equal to negative 20/14, which is the same as negative 10/5, i.e. negative x is less than or equal to negative 10/5. So if negative x is less than or equal to negative 10/5, that means x must be greater than or equal to positive 10/5. Right? Fifths, where the fifths come from, should be 7. 14 divided by 2 is 7. Simple mistake. 7, 7. Okay, great. All right, so 10/7 will work in the inequality, which you can verify in any number bigger than that. So as long as x belongs to the interval bracket 10/7 comma infinity, any number in that interval will work. So just keep in mind why I'm doing this last step a little bit differently than you may have been taught. For example, if I have negative 2x is less than or equal to 10, and I write this. This is actually not right, because until I write this next term, this sign still is read or written as less than or equal to, which is not true. Because when I divide both sides by negative 2, that sign should change simultaneously when I do that. So technically this is right, because the next thing you'll write is x is greater than or equal to negative 5. This is right, but the statement that is written here is actually wrong. So I'm making that subtle thing because there is a difference that a lot of people definitely seem to take for granted, and I'm just making sure that everyone understands that that is true. Another type of inequality that you may encounter is sometimes called a compound inequality, where there's 2 signs being considered. So for example, negative 4 is less than or equal to x is less than 3. So any x that's sort of between negative 4 and 3 is going to be held true. So we can rewrite this as x belongs to the interval negative 4 comma 3. Bracket on the negative 4 because it's less than or equal to, and parentheses on the 3 since it's not including that. So let's solve a more complex compound inequality. For example, negative 2 is less than or equal to 2 minus 3x divided by 4 is less than or equal to 1/3. So what I'm going to do is I'm going to begin by multiplying both sides by the LCM of 4 and 3, which in this case is going to be 12. So I get on the left-hand side, minus 24 must be less than or equal to 2 minus 3x, and that's going to be less than or equal to 4. Next, I'm going to subtract 2 from all sides. So from here, I'm going to have minus 26 is less than or equal to minus 3x is less than or equal to 2. Now I'm going to divide all sides by 3. So the 3's will cancel. So I have minus 26 thirds is less than or equal to x, negative. That's less than or equal to 2 thirds. And now I'm going to apply my negative inequality theorem. So if negative x is trapped in between these two numbers, I can take away the negative and flip the entire inequality around to say that negative 26 thirds is going to be, so the positive of that is going to be greater than or equal to positive x. And let's see, did I miss an inequality sign? No, everything's right. And that's going to be greater than negative 2 thirds. So that's one answer, but a more appropriate answer would be that negative 2 thirds is less than or equal to x is less than or equal to 26 thirds. So this is going to be more valid. Oh, and just a side note here, there seems to be one slight misprint. There should be a 3 here because 12 divided by 4 is 3. So therefore this is going to turn into, what would that be? Negative 24 is less than or equal to 6 minus 9x is less than or equal to 4. So that means minus 30 is less than or equal to minus 9x is less than or equal to minus 2. So that means x must be trapped in between 2/9 on the left and 30/9 on the right hand side. So sorry for that mistake. Always be sure to go back and check to make sure everything is working. So we're going to have that 2/9 is less than or equal to x, less than or equal to 30/9 as the correct answer. Always be sure to check your answers, just in case you make simple errors like I did. No one is perfect, so I'm not going to try and pretend that I am any more perfect than anyone else, or less perfect anyway. So in interval notation, that's going to be 2/9 comma 30/9. So any number between 2/9 and 30/9, for example, 3/9, 5/9, 29/9, will satisfy. So that would be your final answer. Anyway, I hope this helped you sort of figure out how to solve linear inequalities, both one-sided and two-sided inequalities. There are some inequalities where it's sort of split on two sides. For example, x is less than negative 2 and x is greater than 3, where on the number line it sort of goes in two directions, namely the left-hand direction and the right-hand direction. So negative 2 there and 3 there. But this is not usually encapsulated by linear inequalities. This is usually covered in absolute value inequalities, which we'll get to eventually. So I hope you're a little bit stronger now with linear inequalities, and I'll see you in the next video.